Okay, everyone. So this is the third part of the electrophilic addition reactions. So we've been discussing about the electrophilic addition reaction based on Markovnikov and anti-Markovnikov, and followed by the NGP participation. Okay, neighboring group participation, which is discussed for the cyclic amines. Okay, so as I given the last example as a question for workout. So this was the question. So OH. So this is alcohol. So if this is treated with bromine, okay. So electrophilic addition reaction, what could be the product? So for this, the product will be with NGP. So initially, double bond will act as a nucleophile, so that one bromine is going to add to the system. Okay. So if carbocation adding here, forming here, bromine will add here. Okay. If at all carbocation forming here, bromine will add here. Okay. After that, whatever it could be, it's going to be form cyclic bromonium ion. Okay. So cyclic bromonium ion formation will happen only when bromine is present. Instead, if chlorine is present, it's not going to happen. Okay. So after this, OH can attack from both the sides. Okay, so these two sides can be attackable by the OH, but the thing is, wherever high carbon attachment, that is what high steric hindrance or more substituted carbon is with more steric hindrance, so OH will attack from the less substituted carbon. So this is going to be the carbon attachment, so OH attacking point. So bromine will get added to the more substituted carbon, and then this oxygen of the OH will be going to attack here. Okay, so it become plus and this become H. Okay, so now H plus will be left. Okay, so resulting into the pi cyclic product. Okay, with bromine. So this is the answer for the yesterday's question. Okay, what I asked during the class for the workout. Okay. So these are not directly expectable products, but the thing is you can able to write when it is observed by the mechanism. Okay, when it is observed by the mechanism. So one more question I have given, I think. Let me see the question. So yeah, another question is this. So if it is bromination, what could be the product? Okay. So I told you to work out. So I think no one is having time to spare with these examples. So that I couldn't get any answers from you guys. Okay. So if you are being that much busy, it is not good for your preparation. So try to spend little bit more time so that you can able to do the questions from the expectable topics, so that you will at least get whatever you are expecting to get the marks. Okay, so ఎక్స్పెక్ట్ చేసిన టాపిక్లో నుంచి అయినా మీరు పర్ఫెక్ట్గా చేయగలిగితే అది బెటర్. ఓకే, సో అలా చేయాలి అంటే మీరు వర్కౌట్ చేయాలి, క్వశ్చన్స్ ప్రాక్టీస్ చేయాలి. ఓకే, సో నౌ దిస్ ఈస్ గోయింగ్ టు బికమ్ ఎలక్ట్రోఫైల్. ఓకే, అండ్ యూ నీడ్ ఏ న్యూక్లియోఫైల్ ఫర్ ది ఎలక్ట్రోఫిలిక్ అడిషన్ రియాక్షన్. So among these two nucleophiles, okay, so nitrogen is a nucleophile because of the lone pair, and double bond is a nucleophile because of the pi bond. Okay, so when it is a lone pair, it is easily donatable when compared to pi bond. Okay, because lone pair is available comparatively free when compared to pi bond. This we already discussed. Okay, so lone pair is going to donate to the pi bond. Okay, and this is going to attack on the bromine. Okay, so why not attacking at this position means if it is happening, it will be going to give only 4 membered. So 4 membered is little unstable. So it will attack with the 5 membered ring system. Okay. So it got attacked here and this become plus and this become NH. Okay. And this bond is going to attack on the bromine. So it will become bromine and Br minus left. Okay. Minus Br. Okay. Now the H plus is also going to leave as it is going to leave as a acid or H plus so that it will stabilize the system. So this will be the product. Okay. So what you thought the product if it is like this? This is not going to happen because NGP is going to take place. Neighboring group participation is going to take place. So the product will be completely unexpected. Okay, bicyclic system. So to make perfect about these questions, you need to at least try. Okay, so what could be the possibility? Then only you are able to hold these kind of questions. Okay, so if you need to write, you can write or take the screenshot. Okay, if you want to repeat, just comment or you can also discuss in the Google Meet also. So let me know if you want repetition or otherwise I will go for the next example. Okay, so going for the next. So the next example, this one. Okay, so this one is going to give this product. Can you write the mechanism when it is bromine addition? Okay, Django, you want repetition? Okay, I think you are a little bit slow. Please forward. Okay, no, this is not happening. Okay, so what you want? You want repetition of second? So if this is the case, okay, and double bond is here. When a double bond and lone pair having nucleophiles are there, lone pair having nucleophiles, nucleophilicity will be more. So it will be showing its nucleophilicity first. So it will attack on the pi bond so that it is going to attack on the bromine. Okay. So resulting into the formation of a bicyclic system with a carbocation here. Okay. This carbocation and this is what carbocation sorry carbanion because this pi bond shifting here, so that's carbanion is going to attack the bromine. Okay, so resulting the formation of carbon and bromine bond. Okay, carbon and bromine bond. At the same time this is unstable, so it releases H plus, so resulting product will be this one. Okay, resulting product will be this one. Okay, this is the final product. So next, so if it is bromine, this could be the product. What could be the mechanism? If anyone able to write, they can write and send it by the WhatsApp. So let me write the mechanism. So initially, bromine is going to attacked by the nucleophile, olefin nucleophile. So it's going to become Markovnikov rule. Okay, so it's going to follow the Markovnikov rule. So where it is going to attack? So bromine will attack on the less substituted position so that it will give more stable carbocation. Okay, so more stable carbocation will generate accordingly. So this going to stabilize by the NGP. Okay, so here also NGP is possible. Video is not visible. It's like this. Please follow the YouTube. Today, due to technical error, video is not possible. Okay, so I'm just following on the YouTube. So watch it on YouTube. You can find the video as well as the audio. I'm streaming live. Okay, so NGP participation is going to happen with the lone pair. So on the carbocation, so what is going to happen is this is carbon which with two methyls, and this is oxygen which is with OH, and this is going to form a bond and it become positive. So and this is bromine. If I rewrite, okay, so these are the four carbons down to this. Okay, 1 2 3 4. Okay, so here I need to write bromine. Okay, so these are the two carbons which are upside. Okay, so that I am writing like this. Okay, so one methyl is here and two methyls. Yeah, two methyls are here. Okay, and OH is added to here. Okay, so this is not a product, so product is different. Okay, so let's see the product. So and bromine is here. Okay, and this H plus will leave to stabilize the system. Okay, so this could be the product. Okay, only one NJP, so final product will be going to appear like this. Okay, if you want to write in cyclic system, it will be like this. So this will be the product. So this is called board shape of cyclohexane. Board shape of cyclohexane. Okay, so these are all questions what I am writing or today's discussion what I am doing. are already repeated questions in previous examinations like IIT JAM and HCU, and very rarely BHU and other things. Okay, so these are most repetitive questions based on NGP and electrophilic addition reaction. Okay, so don't be confused. Wherever the lone pair is there, that's going to attack on the carbocation system. Okay, so that it will stabilize and it will form the stable product. Okay, so that could be the main reason for the product. Okay, is it understand? Okay, let me write another example. Addition of H plus will result into the what kind of product? Option A. Option B. Option C. Option D. B and C. So mention your answer quickly. So what could be the answer? So let me write the mechanism. So H plus is what? Electrophile. Okay. And this is what? Nucleophile. It will be going to abstract the H place. Okay. Resulting into what? So this is OH. Okay. So this is what place and this is H because Markovnikov rule. Okay. So Sidhu has given B and C. Oh, perfect. See, no. So B and C is the correct answer because these two are same. Okay. Hmm. So this is the stable carbocation that is going to generate with the Markovnikov addition. Okay. Again, it's going to stabilize. Okay. So if I write, so this is two pi bonds, two methyls, and this is oxygen. So it's going to form the bond. Okay. So here it is a methyl. So this become H. So which will be eliminated as H plus. So if I write again, Okay, so this is a product. If I rewrite it as a boat form, so these are the four carbons down. Okay, these are the two carbons other side. Okay, so this is the boat form, and boat has one carbon which is with two methyl groups. Okay, and then oxygen, which oxygen is attached to again bridged carbon, and bridged carbon it is methyl. So this is this and this is this. So option is B and C. Okay. Let's have one more question. I have taken cyclooctane system, cyclooctatriene, which is treated with bromine. Okay, so what could be the product? Option A, uh, in chloroform solvent. Option A, beer and beer. Option B, beer. Option C, option D, none. So what could be the product? Try to think and try to find out the best possibility. If not also okay, I'll give one more example like this. Okay, so let me explain. So initially pi bond will be going to attack onto the bromine. Okay, so resulting what? Carbocation generation. There is a two possibility of carbocations. Okay, so if this is there, this is allyl carbocation which is more stable compared to this. So bromine will attack here. Okay, so again after bromine formation, it will be cyclic bromonium and also carbocation also stable. Okay, so once this carbocation is formed, it will be conjugated. Okay, it will be conjugated to this. Again, this will be conjugated to this. Okay, now NGP will work out, which will stabilize more because the ring size is more. Okay, so this NGP is more stable, so it will be going to give. Okay, so cyclic bromonium which is more stable because of the ring size is maximum. This is 5 membered, most stable. Okay, and other side also a larger ring is there which is not strained. Okay, now another bromine which are Br minus is going to attack on either of the side, which can give the same product. Okay, so this bond is moved towards this. So let's get this. So final product will be like this. Okay, so if I call in terms of addition, this is 1 2 addition. If it is 1 3, 1 4, 1 5, 1 6, so it is what 1 6 addition is the final product, because cyclic bromonium ion formation which is stabilized by the 5 member and large ring size. Okay, so and conjugation also. Okay, so option C is correct. Okay, so how do we know, sir, if we don't see this kind of examples? So you need to follow the stability rules. Okay, so comparatively, this cyclic bromonium ion is most stable. You need to make that cyclic bromonium ion. Okay, so if that stability is more, then it is going to give the final product. Okay, so this kind of examples will be found in the previous examples. So watch the videos of the previous questions. Okay, follow all the previous questions. Okay, you can also find the previous question in Arihant series. Okay, Arihant IIT Jam previous papers, and as well as career endeavor is also provide the previous papers. Okay, so you can also find them. This is Delhi Institute. If anyone goes to Delhi, you can also find. Okay, so these are also available with me. Okay, so you can take the xerox also. Okay, so this is about the previous questions. You need to follow previous questions so that you can make perfect of these kind of examples. Okay, so next, A, and it is H plus, and the product is this one. Okay, so what is A? Option A, option B, option C. Option D, and B. So if the question is like this, so how to solve it? Thing is, you need to try and test whether is it going to give the final product as expected or not. So this is called trial and error method. So take A, okay, and add H plus, and further do NGP. Will it be going to give the product? If it is okay, it's correct. Again take this. If it is giving the product, it's correct. Okay, if not, it is wrong. If not, it is wrong. Okay, so find out the correct answer. So what could be the correct option? So someone is saying A, someone is D. So correct option is D. Okay. So because when I add H plus to A, okay. So sorry. First, initially double bond will be going to take up the H plus, resulting what most stable carbocation here and H is here. Okay. Now this is going to attack, so that it's going to give the product of six member. This one. Okay. So OH will come plus this H plus will be eliminated, resulting into this product. Okay. Again, if I do H plus treatment to this, so this is also going to attack. Okay. So resulting into the again carbocation formation here only, because this is the most stable carbocation. Okay. So again NGP. So resulting to this to this. Okay. So both A and B going to give. So if it is C, what could be the formation? Okay, let's see. So if this is there, here is the carbocation formation, here is the carbocation formation. So this is 2 plus 2 hyperconjugated structures. Okay, here also 2 plus 2 hyperconjugated structure, but this is minus I group, this is plus I group. So here the carbocation stability will be more, so carbocation will form here. And if at all NGP is forming, it is a 4-member ring that is not stable. Okay, so which will not result into the expected product. Okay, so good response, but Srinu and Sidhu. Okay, so you are giving good response in good timing. Okay, so only thing is to expertise these kind of questions, you need to make mechanism habituation. Okay, you should not directly give based on the hypothesis. Okay, so you should not expect this going to this going to this, it's not like that. So you need to go with the mechanism. Okay, so that it will be able to give accurate answers. Okay, so let's try some more questions. So this is another different kind of example. So if this is treated with HBr, hydrobromination, okay, so what could be the product? Option A, option B, option C, A and B, option D, none. So before letting you to write the mechanism, I will explain something. Okay. So this is a bicyclic system. Okay. On a bicyclic system, there are two kind of the substitutions. Okay. So this is tetrahedral carbon. So the carbon bond which is above towards upside, okay, this is called exo addition. Okay, exo substitution. So if any R group or anything is there, this is called exo group. Okay, which is towards the down, because this is tetrahedral carbon. Okay, so it will be like this. Okay, So which is looking upward is called exo, which is looking downward will be called as endo. Okay, so this is also exo and this is endo. Okay, so total carbons will be like the same, one and the same. Okay, all with exo and endo substitutions. Okay, so when a double bond is there, okay, so if it is a double bond, it will be from upside, these are the two hydrogens. From the downside, these are the two hydrogens. Okay, and these are the hydrogens. So this is kind of system which is present. Okay, so when this is there, there could be a possibility of attacking the bromine. Okay, towards the upside. Okay, పై నుంచి అటాక్ అయితే కింద నుంచి అవ్వదు. ఎందుకు అని అంటే కింద ఈ హైడ్రోజన్స్ ఏవైతే ఉన్నాయో అవి రిస్ట్రిక్ట్ చేస్తాయి. ఓకే, దే విల్ రిపల్స్, దే విల్ స్టీరికల్లీ హిండర్ ద బ్రోమిన్ విచ్ ఇస్ నీడ్ టు అటాక్. ఓకే, సో దిస్ pi bond is able to attack from the upside. Okay, resulting into the product of so let's say bromine is attacking here and carbocation is here. If the other way also same, this carbocation one and the same. Okay, but it is from the exo side. Okay, exo side. After this, what's going to happen? Generally NGP is going to happen, but there is no groups such resulting into the NGP. Okay, now what's happening? This is a bicyclic system. When a carbocation generates, is going to give non-classical carbocation system. Okay, so we studied non-classical carbocations. Okay, so that is happening only in cyc bicyclic systems with sigma bonding NGP. Okay, so it's going to give a hybrid of the non-cyclic carbocation. So it will be indicated with the dashed bond. Okay, so after the non-cyclic carbocation, it's again going to result another kind of this I am erasing. Okay, so resulting into the another carbocation which is here. Okay, so this and this both are same, which are transmitted are converted through non-classical carbocation. Okay, so when it is, sorry, here it should attack we have taken HBr, no? Okay, so here it should attack H plus. Okay, H plus, so H plus, sorry for that. So H plus is the electrophile, nucleophile is double bond, so it will attack H plus. After this, bromine. Okay, so if it is bromine attacking, again it should not come from the downside. Okay, it will come from the upper side, which is a less steric side. Okay, so it will attack, so resulting into the product of bromine and H towards the same side. Okay, so hydrogens, and if this is there, this is also going to attack from the upside. So this is one. If I write hydrogen or if I didn't write also, it is same. Okay, these hydrogens, if I write also not, if I didn't write also, they are present. Okay, so this could be the product. So at any possibility, if you can see, it is Br, that is from exo. Okay, exo. So exo addition is going to happen. So correct option is A. Okay, so this is endo addition, which is not possible. Okay, is it understand? Is it clear? Okay, let me go for another example of similar kind. These all are previous questions. You can look into the previous papers. Definitely there will be a question like that. So earlier it was hydrogens, now it is methyls. If this is treated with HBr, what could be the product? Option A, option B, option C, A and B, option D, none. So here the hint is when there is no methyls, the downside will be hydrogens which are going to sterically hinder. But when there is a methyls, the upper side will hinder. Okay, so only down attack will be going to happen. Okay, only down attacking will be going to happen. So what could be the product? So give your option. Sidhu, yeah, exactly correct. Because now anyhow it's going to abstract the H plus. Okay, so it's going to abstract the H plus, which is from the downside. Okay, so H plus abstraction and bromine addition will also be downside. Okay, so because of the steric crowding, so H plus abstracted, so it become the carbocation. So either of the sides same. Okay, so you can also write this side also. Okay, so when it is bromine minus, it's going to attack from the downside because upper side is sterically hindered. Okay, the symbol indicates steric crowding. Okay, so it will be Br. If I rotate this molecule 180 degrees, so this is going to become, okay, so it is one and the same. So you need to write the examples on your notes, or otherwise take the screenshots, write whenever you are free. Okay, but make a best notes because this is the notes that you are going to follow throughout your examinations. Okay, so until unless you don't need to you are not going to make a notes with your laziness, it will not be fruitful to get perfection about this topic. Because once you get the perfection, you need to revise it. Okay, otherwise you will forget about all these techniques and all this information. So to revise the topics, you must need to maintain a complete notes. Okay, so if not elaborated, just try to write whatever the main points that are possible, or whatever the mechanisms that you need to remember. Okay, but you should maintain a proper notes. Okay, So this is about the bicyclic systems. Next we will see based on the reagent system. Okay. So here I am taking allene. Okay. So what is this? Allyl system. Okay. So allyl system, if I treated with NBS, what is NBS? NBS. We've been discussed when it is about nomenclature. Okay, in the nomenclature we are discussed NBS. It is N bromo succinamide. Okay, N bromo succinamide. Okay, so if it is N bromo succinamide, succinamide is this is succinic acid. Okay, four membered bicarboxylic acid. Okay, so if this treated with NH2, it's going to double attack, so that it is going to give. So first this NH is going to give, amide is forming. Okay, again this is going to attack, so that cyclic amide lactam will be formed. Okay, so this is what succinamide. If succinamide is treated with, replaced one of the hydrogen with bromine. Okay, so it is N-bromosuccinamide. Okay, so the N-bromosuccinamide generally in non-polar system it will release bromine radical. Okay, non-polar. Okay, where homolysis is going to happen. If it is polar system, it will release bromine ion, bromonium ion. Okay, so bromonium ion. So here I am using H plus, which is acid, which is a polar system. Okay, so NBS upon H plus treatment, initially what's going to happen is, so H plus will abstracted by the lone pair of the oxygen. This much elaboration is not required. Okay, so simply when it is a H plus or acidic, it will leave Br plus. Okay, how it is going to happen, that we will see here. So this is not going to ask in the examination, but the thing is, it's better to know in detail. Okay, so this become plus. Okay, so this is going to move here, and this will become positive, which will be stabilized by the lone pair of this. Okay, so H and N double one Br, and this is plus. To stabilize this ammonium ion, the bromine will be going to release as a Br plus. Okay, so OH double bond N. Okay, so this unketoenol tautomerism simply going to give N bromosuccinamide. So N minus will come, H plus will be abstracted. So simply succinamide will be byproduct. This is all about byproduct only. Our main reagent is Br plus. Okay, this Br plus will be attacked by the propene. Okay, that is what aniline. So is it going to follow Markovnikov rule? Yes, it is, because it is unsymmetrical olefin. So it's going to give Markovnikov and oh sorry. So more stable carbocation here and bromine will be here. Okay. So till this it is okay, but here we also taken up the H2O where OH minus is available as a nucleophile. So when it is OH minus nucleophile is there, that's going to attack again, so that it will become OH and this become bromine. So this could be the final product or major product. There might be many possibilities, but major product will be this. Okay, this is going to happen from the NGP also. Okay, after NGP this is going to give. So overall if I see, the product will be OH and Br. Okay. So sometimes it may be asked mechanisms. Okay. Sometimes it may be asked in statement. What could be the electrophile that is generating with the reagent system? So in with this reagent system, the electrophile will be bromonium ion. Okay, bromonium ion. Okay. So resulting into what? So a mixed nucleophile attacked product. Okay, not dibromo system. It is hydroxy bromo system. Okay. So reagent system is polar, so it is released bromide bromonium ion. If it is non-polar, if it is simple NBS, non-polar system means carbon tetrachloride, okay, or benzene. If it is non-polar, it's going to give bromine radical, which will be studied in free radical addition reaction. Okay, in the next class, we are going to see the free radical addition reaction. There we will be going to read how it is going to give free radical addition reaction. But reagent system is N-bromosuccinamide in non-polar solvent. If it is N-bromosuccinamide in polar solvent, it will release bromonium ion. Okay. So write that points also. In polar, it's going to give bromonium ion. In non-polar, it's going to give radicals. Okay. So workouts for today. NBS H plus, and here I am taking methanol. So yesterday also I have given one example with the methanol. Okay. So what could be the product? Write the product and submit in the WhatsApp. Okay. So everyday submission should be there because I am giving everyday workouts. So if you follow the class and follow the workouts, then it will be complete. Otherwise, it will be incomplete preparation. Okay. H2, 3. This is propargyl alcohol. Okay. So if it is double bond is there, let's say NVS by H plus. If it is penile system attached with carbon. Okay. So 3 carbon with a double bond, allyl system. Okay. And so this is allyl alcohol. Okay. And same 3 carbons with a triple bond system. So this is propargyl. Okay. So it is propargyl alcohol. Whatever may be the alcohol, what could be the product? Okay. Mm, next. One, two, three, four, five. Okay. So if this is treated with NBS by H plus, so what could be the product? So try to write the products, okay, and submit with the earliest possible, okay, so that I can explain more about this kind of reactions, okay. So tomorrow we are going to see the stereochemistry of addition reactions with the different reagents, as well as the substitution reactions if time permits. Okay. So that's all for today. Thank you.